Hello everyone, welcome to the Logical Loop channel. Today we'll discuss another useful problem of the day. The problem number is 2661. First, completely painted row or column. The given statement is like you are given a a base index integer array, and an m into n integers matrix mat and array, and mat and array both contain all the integer in the range of 1 into like 1 from 1 to m into n range. Okay, go through the each index I into the array starting from the zero index and painted the cell into the mat containing that integer of array I. Okay. And written the smallest index I at which the either a row or a column will be painted. Okay. So in this question, what we need to do, like first we need to go to that array element, like we go to that one, and in that mat we have painted that one. Then we go to the three, and in the mat we have painted that three. And then we go to the 4, we have painted to 4 into the mat. Okay, so at 4 we have like painted this row or like this column. Okay, so we have painted one row or one column. Okay, so then we will need to return this 4, like 4th index, like at like 0 1 2. So at 2 index we have painted one column or one row. Okay, like that. So the brute method in this for this problem can be like we are traversing over the array, and for the array every array element we are traversing over the mat, and we are like painting that element into that matrix. Okay, so for making it ease for traversing over the matrix, what can we do? We will use the map, and we will store that matrix element with that row and column with the row and column, like, and that index value. Okay, so I have written for the explanation, like this can you follow. Let me paste it here. So let me zoom this. Yeah. So what is saying? Like in this we use this map, and in map we put the value of the mat, and when we iterate over the array we will mark the mat value from the map, and then check for row or column is painted or not. Okay. The time complexity I will explain later. Let's see how can we do this. Like first of all we will take mat dot length, and will be this column length. Okay, we will take a map. Okay, now tra traverse over the traverse over the map and store value with row and column. Okay, so we will like row will go till n, row will plus plus, and for column go till m. And here what can we do? First of all, let's take a current value like this, and row and column. And in map dot set, what can we do? We set the current value with that row and column. Okay, now we need to traverse over the array to find it. Okay, now traverse over the array element. Or let I equal to 0, I will go till array dot length I plus plus, and like here we'll take the value of that array of I, and for this value we will need to find that row and column. Okay, so what we will do, like row and column, for this value we will get from the map. Okay, and in that mat, for this row and column we will paint it like mat for this row and column, paint that block. How can we paint? We will multiply with minus 1. Okay, because the range of the elements like it is from 1 to 10 to power 5, and 1 to like 10 to power 5, and like 1 to. Okay, so we will multiply with minus 1, painted that cell. Okay, now check if row and column is painted or not. Okay, so if check row painted, we will send the mat, we will send the row, and then we will check column painted, we will send the. Okay, and we will return this particular I, otherwise we will return the minus 1 because we did not get it. Now let's write this check row painted. painted. Okay, we will have the okay, we will have the row and we will need to traverse over the column for checking. So for column equal to this and column will be mat this and column plus plus. If mat row column is greater than 0 means it is a positive value, then we will return the false because it is not painted, otherwise we will return the true. Why we are checking like over like greater than 0? Because we are multiplying with minus 1. Okay, that's why. Like if any that mat value is less than 0, then like it will return the true because that is painted. Check column painted. We will have the mat, we will have the column. So we will have the column, so we need to traverse over the row, and for row we will traverse like this. This is also same like if mat row column is greater than 0, we will return false, otherwise we will return true. Okay, let's see, right, run it. Okay, we did not get the space here. Okay, so all these test cases passing. So the time complexity is here, like here for like setting into the name, we are iterating over the like nested loop, so n into m, and here for every array of element, we are checking for this check row is painted, check column is painted. So like s time this and this n plus n time this. That's why the overall complexity time complexity is n into m plus s into m plus n, sorry, m plus n, yep. And the space complexity is because we are taking map, and in this map we are iterating over 2 times and setting that value of the row and column, so that by the this space complexity to n into m. Okay, but this will give you the time complexity. Okay, because that constraint is small, like this is large, like 10 to power 5. Okay, so we need to think about the optimal approach, and in the optimal approach, what can I think of here, like we need to, like in this, like for every row and for every column we need to find the last index till that every element into that row or into that column will be painted. Okay, and for that every last index from those last index we need to find the minimum one. Okay, because at the minimum one we will have at least one row or one column is painted. Okay, so let me write this into a code form. I have the explanation also written. Let me, yep, this one is written here. Okay, so what is saying? In optimal method, we need to use the reverse map. Reverse map is nothing because like in the first method, we are using map for this matrix. In this, we will use for the array. Okay, so that's why I have written like reverse map. Means we need to use map for the array and place all the element for the array into the map. Then we need to traverse over the row and column one by one, for like for the every time for the row we will need to check like what is the last index, and then we will need to traverse over the column one by one to see what is the last index in every column. Okay, and then we will maintain the last index, and then we will find the minimum index from all these last index. Okay, so let me write this. Mat will be this, and m will be mat this. Okay, we will take a map. Okay, now traverse over the array for like value will be array of I. In map we will set we will set that value with that I. Okay, now we will take a minimum index which will be returned. We will take like infinity. Okay, now traverse over the traverse over the traverse over the row one by one to find the last index. Okay, for let row will be 0, row will be n, row plus plus. In this, we will take a last index, which will be -1, and for column will be 0, column will go till m, col plus plus, and if, no. In this, we need, okay, so let's take a current value, will be mat of, this row and column. And for the IDX, we will get from that map get, okay, and we will find the last index equal to math dot max last index IDX, and after that we will minimum index math dot minimum index and last index, okay, last index. Same we will do for the column. Now traverse over the column one by one. So for let column, we will take a -1 and we will row and row plus plus. Let current value will be mat of row and column. Let idx will be map dot get current value, and last index will be math dot max last index that idx. Okay, and in this we also like min index math dot min index and and sorry last index. After it we will return the main index. Okay, let's run it. Okay, let's see. uh where null is not a valid. Okay, map dot row into column idx map dot getting current value, and in this last index, okay, infinity. Okay. Yep, let's see. Yeah, so all the test cases passing, and in this the time complexity is like n, and here we are traversing over like n into m, and here is also like n into m, and the space complexity is we are taking some map for this array, so the space complexity is n, so that's why n into m plus n into m, the overall time complexity is n into m, the space complexity is O of n. Okay, let's submit it. Okay. Yeah, so all the test cases passing. I hope this you guys understand it. Thanks everyone.